Hello and welcome to this talk where I will present about PARCH, Volvo's take on composable architecture. Maybe you have heard MVP, MVI, MVVM, UDF, now PARCH, yet another Android presentation architecture. Do we need another architecture? Let's see if by the end of this talk I can answer that question. But yeah, let's start with some introductions first. Who am I? Juan Chiaradía. I come from Argentina. I've been living in Sweden for the last 10 years. I moved to Sweden because I love surfing, of course. But lucky for me, Lisbon has a DroidConf where I can come. I've been working as a software engineer for more than 20 years now. And since 2010, I've been focusing my career on Android applications, particularly. I've been working for Volvo the last 6 years, where currently my role is a staff engineer behind the mobile core of the app. But yeah, enough about me. You didn't came here for me. You came here to learn about PARCH, what is PARCH, and how can that help you building better apps, hopefully. Or that's the bet, at least. But before jumping into PARCH, let's take a step backwards and talk about architecture in general. Nowadays, it's quite common for an Android architecture or a mobile architecture to follow a simple 3-layer clean architecture, where we have a presentation layer and a domain layer, both dependent on the domain layer. Presentation and a data layer, both dependent on a domain layer that is agnostic towards both of them. Where the presentation consumes our domain values to show a UI on the screen. The data will provide the specific implementations for our domain definitions, and it will provide access to database, to the cloud, and through the cloud, it will provide access to the real world. So let's try to zoom in on our domain layer. Before that, let's talk about application state. Every application has a state that will tell you what you will end up presenting on a UI, how you will end up reacting to different behavior, different events. Wrong door. And this state is implicit of what is happening on the memory on the device that our app is running. Okay, sorry for that. Okay, where were we? Let's see when we will get disturbed again. We needed some icebreaker, right? So we were talking about the domain layer. We were talking about application state, how the object instances that live in the memory will define the application state. Why is this application state important? Those objects, the values that they keep, they will have their own life cycle. They will change from different events. And as a reaction of those changes, our UI or how our app behaves will change. I'm pretty sure that you have faced a bug report that feels random, that is hard to reproduce. Or whenever you are building a new feature, you want to test that feature, you want to bring your app to a certain state, right? That's why the more control we have on that state, the easier that will make our life as a developer. All this to say that immutability on entities is good, that we, from our domain, we will expose immutable entities. And those immutable entities will be the input for our UI to be present. But immutability on its own is a bit boring, in the sense that there wouldn't be life without change. We want our app to be able to change the state. We want to react to the real world changes and represent it on the app. We want to react to user interactions. How do we do that? We do it through use cases that will act on the immutable entities, create new entities, new immutable entities, and publish them for our UI to update. Okay, that's a bit of a brief of a high-level architecture, clean architecture. More likely nothing new here. How does PARCH fit on this? PARCH will help us to structure the presentation layer. It doesn't really bring new concept. Mostly it's a cherry pick of all the different architectures, as I mentioned before, MVP, MVVM, MVI, and adopting what it makes sense for us, dropping what it doesn't make sense for us, and with a strong sense of single responsibility and focusing on the single responsibility principle. So in between the main components of PARCH, we have the Compose UI that is in charge of drawing a representation of a world in a canvas. The canvas will be the user screen. This representation of the world will be given to the Compose UI by our view data. And this representation of the world will be created from composing or combining, mapping all the different, and there we go again. Okay. Good thing that I started earlier. So the view data will be combining the entity, the domain entities, into the values that are needed for the Compose UI to be drawn on the canvas. But then we have the interactions that the user does, and our Compose UI already have its single responsibility. We don't want to pollute our Compose UI with an extra responsibility. And that's where what we call orchestrator comes into play. All the interactions that the UI will receive will be forward to the orchestrator. The orchestrator on its own can decide if the interaction is a navigation or if it's a use case that has to be triggered. The orchestrator doesn't know how to play the instruments. The musicians here are the use cases or the navigation, but the orchestrator decides when each of the things has to happen. Now we have a brief understanding of the relationships on the different components, but what does it mean in practice? Can we be more specific about these components? Let's see a common data flow and how that is solved within this architecture. First, let me showcase a bit of the app. We are showing a snapshot of the car status. We want to show as much as possible the real time of the status of the car. If you open the door or close it, we want to show an overview if your climate is running, if the charge is running, if you forgot it unlocked or not. So how our UI will get updated by this? We say already that the Compose UI is the one in charge of drawing on the screen. This Compose UI depends on the view data to get the UI values. And the view data on its own can depend on the car status flow, Kotlin flow, that will publish immutable entities. That means that the data flow is actually the other way around, right? So whenever our real car updates the status without getting into what happened in between there, going to the cloud to the data layer, reaching the domain layer will publish a new car status. This car status will be observed by the view data and be transformed into the UI values that are needed. These UI values will trigger a recomposition on the Compose UI, updating what the user sees on the screen. It's quite straightforward, quite linear so far, right? Does this relate to what we see on the code base? So far, we focus on the log portion of the screen. Let's see how we can code that part in. So we start with the Compose UI, where we define our role. We want to show the icon that represents our log's status. This icon is calculated by the view data. And we are collecting as a state, relying on the composable features from Jetpack Compose to trigger recomposition whenever it changes. And this will happen every 5 minutes, sorry. Okay, we are back, thank you. Sorry for the people online. Hopefully you are still there. So we were checking how do we react to changes. We saw this part already. So the Compose UI is depending on view data values that are calculated from our car status flow. Whenever a real world event happens, we will publish a new status immutable. It will be converted into UI values, and then it will be recomposed. As I mentioned, this is quite straightforward, quite linear. Let's see if that relates to the code base. We will start with a row. On the row, we have a log icon that will come from the view data, and we support ourselves with collector state. The same will happen when we want to show the status text. As well, we come from the view data, and it will recompose whenever a value changes there. I will skip the Compose UI test because we won't have time. But let's see how do we go and test the view data with this approach. Before that, we should write the code of the view data. But yes, so this is the code of the view data. As well, it's quite straightforward. What's the view data does? It exposes, it reads the domain. It exposes 2 values for our UI to consume, and those values are calculated from mapping the published immutable entity. We can, if we like, rewrite this on a more single responsibility way by following extension functions, but the complexity is the same and the code is still the same. So we have pretty straightforward mapping here. We can go and check how it relates on the test. For testing this, we will need our test subset that we create on every setup to make sure that we are testing a new subset. We will fake our dependencies, the domain logs flow. You could use your favorite mocking library for this. Spoiler alert, if you use a mocking library, it will take twice or more the test to run. If it's simple enough, I recommend fake it. But Mockito or Mock-K are powerful as well. And if we want to test how the text ID is created and if we are publishing the right values, it's as simple as that. We inject a new value into our fake domain flow, and we verify that the expected value is the one that is published by the view data. For this, we are supporting ourselves into JUnify capabilities, which are parameterized tests. This one will give us the control values for our test that are the ones that we are comparing against each other. Then we have a test for the text ID. We can write pretty much the same for the icon. And then we would like to test as well that whenever a view data is created, we are consuming the right log status for the right VIN. What is a VIN? Vehicle identification number. That's a general thing for every car. So that's how we are going to tell this is the car that I want to listen the status from. So to recap this part, whenever our car publishes or changes the status on the real world, our domain will publish a new immutable value that our view data will convert into UI values that eventually will trigger the recomposition, and our UI will get updated. Well, that's about the data flow, one direction. We want as well to be able to interact with the app and to be able to force changes. So imagine that you forgot your car unlocked. Instead of running to the car and lock it yourself, because your app, the app is telling you your car is unlocked, you can just open the locks screen and trigger a remote lock that will lock your car. So how does that go into the app code base? Let's start with the navigation. We know that the Compose creates the screen. Whenever we click on it, the Compose will forward that click to our orchestrator. Our orchestrator in this case has a responsibility of deciding what to do with that click, right? And here what the orchestrator will understand is, as a reaction of this click, I need to tell the navigation to navigate to a new screen. The navigation eventually will trigger a recomposition. Spoiler alert, here we are using Compose navigation under the hood to update our UI and show the new screen that the user should be there. On code base as well is not rocket science. We will need to alter our row, so we add the clickable modifier, and we just forward the on click to our orchestrator. Of course, because of that, we need the orchestrator as a dependency of our UI. And the code on our orchestrator, again, is pretty simple. We have a single dependency on the navigation, and the orchestrator tells the navigation where to go as a reaction of the click. Here we could add analytics as well. We could add any of the observability metrics or extra logic that is not given by the navigation. If we want to test the orchestrator, as well, it will be quite straightforward. We create our subset of tests, the orchestrator. We fake and set up our navigation. And then we test that whenever a click happens on a VIN number, we are navigating to the right screen with the right parameters. As well, using parameterized tests. It's always good to test with at least 2 or 3 values. Try to, if you have corner cases, try to use the corner values as well. On this case, beings are just strings, so they have a specific format, but we don't care of those here. Yeah, so navigation was easy enough. What about locking the car? What about triggering a use case? The part of a click, we are on the same. But here, the orchestrator will invoke a use case. The use case, through our data layer, will start triggering a set of different logics, calling our backend, sending an invocation to our backend. The backend will send the lock invocation to the car. The car will try to lock itself. But meanwhile, all this happens, we want to give some feedback to the user. So we can have the client logic that while we are waiting there, we can publish a new car status that says locking. The view data will understand that car status and publish the state, the UI state, to the UI for it to give the feedback to the user. Eventually, the car will lock. The backend will notify the app. A new car status, immutable car status, will be published by the domain. That will be understood by the view data as in, let's convert it to a locked screen and a locked UI states. And then that will retrigger the recomposition to update our screen into locked. If we go to the code base, we don't pay much attention to the UI here. We care about the connection in between the UI and the orchestrator. Again, it's straightforward. Every event that we want to trigger from the UI, it will go directly to the orchestrator. The UI shouldn't do any logic on it. The orchestrator is the one that will decide what to do. And then the orchestrator will define that interface to be able to attend those events. I don't know if any of you has implemented MVI before, but model view intent, the intent part of it defines the different events that the UI can trigger, right? Those events usually on MVI are defined as a data type, or a enum, a seal class, a seal interface, whatever flavor you prefer. Instead of those events, in PARCH, there is a correlation to the public API that the orchestrator is enabling to the UI. Instead of having an enum that says lock click event and unlock click event, that is published through the public API of the orchestrator. But the motivations are the same in both cases. Our orchestrator here is triggering the use cases. And then, again, the test for it is quite straightforward. Whenever a click happens, we verify that the use case was triggered on the right way. So if we make it slightly generic, we can say that this is a reactive architecture, where the Compose UI, whenever the Compose UI has an event, it will forward it directly to the orchestrator. The orchestrator will decide what to do with the event, more likely end up invoking a use case that will trigger some process on our data layer, eventually creating a new immutable data entity that will be captured by whoever is observing on it. Maybe one view data, it may be many view data. That view data will convert it into the view state that our Compose needs, and then the Compose UI will trigger recomposition. If you have been in Android documentation, official documentation not so long ago, you may have seen the UDF, unidirectional data flow, where the state flows one way, event flows the other. I hope that you can see the equivalence in the previous event that I showed there. So yeah, hopefully you have a better understanding on the different components, how they relate to each other, how they handle data and events. But we talk about composition as well. We have two levels of composition. One is given by a composable on its own, Jetpack Compose, where we have different composable functions that can be attached to different components on the screen. Each of these composable functions internally can have their own representations. But here we are talking always about pure UI representation. We are not having any extra logic, right? We want with PARCH to bring this composition to the next level. The next level for us is the smart component. Is not just splitting in UI, but if we take this screen, for example, to show in the top view, reacting to open doors, closed doors, or all the images there, we will need to be listening to the car status update, convert that car status into the images, and then trigger the recomposition. On the top, we could be listening to a different entity, car information, and then map that information to year and model and show it on the screen. We could be listening to a car location, triggering a geolocation API and show the address where your car is parked with the weather of it. The same for the battery level. If we have a message inbox for in-app messages, we want the logic of do we have unread messages or not. And for example, here, this part, we saw it a bit. We have what we call remote functions sidebar, or remote overview sidebar, that each of its own, even when they are simple enough, if we put all together, they will get overly complex. And then if we try to map everything on a single UI here, we will start having these issues of app state that changes randomly, right? It's because we designed it to change it randomly. So how we go on it? Each of these components, we can build it as a smart component. And then our UI is as plain as this, where we have a header that only receives the VIN number of the car. Then that component will do all the logic internally. Subheader, battery status, message bell, and we can focus on the control sidebar, right? This remote control sidebar right now has 3 smart components on its own. One of them is the one that we already built. We built the central logs overview UI, but there is a small mismatch here. We are sending a VIN as the argument, while what we built is needing a view data and an orchestrator. So how we map both together? On its own, the view data needs to get the flow from the domain. The orchestrator needs to get the navigation as well. So we have the helper function PARCH that will help us put everything together. And the other thing that you may have seen is the use of dependency injection. We are relying on Coin. It's a service locator framework to solve the problem of dependency injection, but easily this can be rewritten to use HILT. And then Coin will make sure to create the right view data and the right orchestrator to pass to our central logs overview UI. Okay, let's zoom in even more. For Coin to work, we will require to create a scope and define the different factories of our components. In HILT, you do that through annotation. With Coin, you could do it with annotation as well. We find it a bit more explicit and easy to follow, easy to onboard people by being explicit on it. It's not a lot of code that you need to write. It's not code that you need to test neither. So it's a little effort for big gain, on our opinion. Then Coin will know how to create this following those factories. That factory on its own will know that needs to get navigation as well already existing on the dependency injection layer. On this sense, in Coin we will define the different factories for every UI component that we have. We will also define the different factories for our domain, or the implementations of our domain. Now let's zoom in into PARCH Composable. The first thing that we do is to write down the content. This is like any other composable function. But then for Coin to find those factories, it needs a scope. We need to create a scope, and we need to provide it to the composition contest. I don't know if you have used yet composition local, but it's a way of provide extra context to your compositions. On this case, we are providing the Coin scope to be used for our content that is the central logs view UI. So whenever we execute the central logs overview UI and Coin inject try to find a factory, it knows what the scope to create and go and get the factory from there. You may notice that when we created the scope, we are passing an argument there. That argument is to identify which of all the scopes that are defined in Coin we need to create. And of course, it's extra. And we go all the way. It's an extra argument of our composable helper function. Last step that we require here is that whenever we exit the composition, in order to avoid leaks in memory, in order to let all the objects be garbage collected, well, first we need to map it to the parent scope in order to get the navigation. The navigation will be on activity level. Coin has a stack of scopes, nested scopes, and the navigation will be exposed through the activity. And then we need to clear or close the scope whenever we leave the composition, so we are not leaking any memory, any object. Main activity. We have a single activity and no fragments, no nothing, pure UI, compose UIs. The main activity, main responsibility is to declare the navigation and handle the big navigation. We are using compose navigation, and we will be creating the app content there by providing a scope. On this line, declare navigation, we are injecting the navigation into the coin scope. So it's available for every PARCH composable later. Our navigation is a simple interface, navigate to, and it receives a UI. Any UI identifier can be passed to the navigation. And then under the hood, we have an implementation that depends on the nav host controller as well. Quite simple implementation. We added special cases for navigate back and quitting the app. And it's declared on the coin scope on the previous line, as we saw before. Then we have this app content that is defining the navigation graph. In this navigation graph, we are defining all the different UIs that will be a full screen of our app. We can also define if we have a button sheet or not, or a modal, we can define it here. So whenever our orchestrator says navigate to a new central logs UI for this bin, that will be mapped to our navigation graph and trigger the right compose UI that was defined before with its own injected view data and its own injected orchestrator. So for a full recap, we have a main activity that exposes the navigation. Through the navigation graph, we define the different screens where the app can land. Each of these screens on its own can be multiple PARCH components, where each of these PARCH components has their own complexity, right? And we are putting everything together thanks to dependency injection and through coin. Final words. Only 5 minutes ahead. Well. Simplicity is the ultimate sophistication. I'm pretty sure that you weren't amazed by the code base that I showed. Everything was quite straightforward, hopefully. But you can solve complex problems by composing simple solutions or simple blocks, right? Myself, I believe that if a solution is complex, it's because you may be misunderstanding something, either from the problem. And whenever I find myself with a really complex solution, I stop, do a step backwards, and I ask myself, what am I missing here? Because software doesn't have to be complex. The sum of everything maybe is complex, but individual solutions are pretty much straightforward. So our architecture is about clear responsibilities and boundaries. As I mentioned before, PARCH, MVP, MVM, MVI, they are different flavors of splitting responsibilities on a similar way. The rest is mostly code style, how you feel comfortable with. In the whole code base, I'm pretty sure if you pay attention enough, you didn't see any superclass that we were forcing our components to be part of. You didn't see any, other than the declaration of the UI identifier, the rest it doesn't have any restrictions. That can be good and bad, depending on how mature your team is, because with the freedom comes responsibility. But we take it as a good thing. We have minimal dependency toward three parties libraries, and only under the hood. We are not exposing those dependencies to the whole app. If we want to change coin to hilt, we do it only on the dependency injection layer, and all our UI code, all our view data, all our orchestrators, we don't need to touch a thing over there. If we want to change navigation compose for the next great navigation library, we do it only on the implementation of our navigation abstraction. The rest of the code will be untouched. Dependency injection is key. Not much to add there. And then let's see if any of you guess what PARCH stands for.
Presentation, adapter, repository, was the C, and then
You started good, but then bien. Bien. Yeah, sorry, the Spanish came out from me. So yes, presentation architecture. We had that same problem. PARCH is actually an evolution of other architectures that we had. And with that evolution, we changed the names of key players. We had something that was a presenter that now is not a presenter anymore, and we changed it to something else. And then we say, why bother ourselves with these acronyms? Any of them will be a presentation architecture. Then we have the flexibility to change the names as we like without bothering about the high name of the architecture. And with this and all the accidents, we are done. Thank you for staying.